Okay, so we're going to talk about the properties of a square. I think first of all it's going to be important for you to understand like how the branch or the hierarchy of quadrilaterals actually, what it actually looks like. So we have just any normal quadrilateral, okay? And then to get more specific, we have what we have called parallelograms. Then what's happened is we have branched out into a special parallelogram called a rectangle. Remember a rectangle, what makes a rectangle is that it has 4 right angles. And then we have the unique branch called a rhombus, which what made a rhombus is 4 congruent sides. So because a rhombus is underneath a parallelogram, or by definition it is a parallelogram, it has all the same properties. Now, does a rhombus have the properties of a rectangle? And that would be no. A rhombus does not have 4 right angles. Now, what we are getting ready to do today is figure out where in the heck a square comes in. A square has the properties of a rectangle because a square has 4 right angles. A square has all the properties of a rhombus because it has 4 congruent sides, which means that it also has all the properties of a parallelogram. So what makes a square is if you can prove the quadrilateral is both a rectangle and a rhombus. Okay, so you got to prove that it's both a rectangle and a rhombus. Okay, so the properties of a square would be, label this as example 1. So if I am actually given that this is a square, we'll say R, S, T, and U. So R, S, T, and U, and we have diagonals US and diagonals of RT. So if it's a square, and I tell you that this is 5, then I also know that all of the sides are congruent. So that makes all of those 5. Since it's a square, I also know that we have 4 right angles. So I know that each angle is going to be 90. Because it is also a rhombus, I know that we have a right angle here because diagonals bisect. And since it's also a rhombus, I know that if this is, let's say, 42 degrees, because a rhombus bisects the angles, that this is also 42 degrees. That is a terrible, let me try that again. That's to be 45 degrees, which makes that 45 degrees. So diagonals also bisect a right angle. So that means that all of these are going to be 45 degrees. Okay? Let's do example 2. So we have square MNOP. And I'm telling you that this is, well, let's make this 8, and this is 4x plus 4. Okay, so 4x plus 4. Then what is x? Well, these are congruent because it's a square. So I know that 4x plus 4 should equal 8. 4x equals 4, so x equals 1. So if x is 1, that means that this is going to be 8. I also know that in a square, that diagonals bisect each other. So if this is 4x plus 6, and this is 2x plus 10, because it's a square, diagonals still bisect each other. I know that 4x plus 6 is going to equal 2x plus 10. 2x equals 4, so therefore x would be 2. Let's change these to y's. That's a terrible example again. Okay, so y would equal 2. So again, those are just using the properties of a square.